Hello, welcome to the stream. Today we are going to work on refactors. This is the issue on the screen is the most important one. We have a couple of API calls inside CockroachDB for launching asynchronous tasks or Go routines, and they use context.background. And because of this, they do not benefit from our various tracing facilities. And so we're going to fix that. There are not so many of those calls, but to achieve this, we need to wrap up the PRs that we started 2 to 3 weeks ago. So this is mostly too good to go. It's been approved already, but there are some CI failures. So we're going to work through them and get this PR merged. And then after this is merged, we are going to work on this, which I already did some off-stream steps towards. We're going to add a linter and then send a PR for that, and off we go. So that's the plan. However, I was reminded that there is another unrelated PR that should possibly be merged as soon as possible. And so before we do this tracing related work, we are going to finalize this PR here, which also has a CI failure. So in order, summaries, this is here our main goal, issue 73911, which in turn will require finalizing this PR, 72912, which has currently some CI failures. But before we start with that main work, there is a side PR which is unrelated that also has CI failure, and it needs to go today. So we're going to look into those CI failures and fix that. So let's start with this one. I assume this is going to be fast. So let's do that. Slash that. This is all ready to date. Is it really? All right. We are going to look at the CI failure. What is failing here? All right, actually it's not everything. So it's just this one here. This is an automatically generated file. And we see that there is a difference on the output here. So that's very trivial. We can fix that by doing the following. We're going to start the key thing. All right. So, oh, that's the exec builder. Exec builder. What is the directory? Exec builder. Bopt exec builder. We're waiting for this test to complete and to rewrite its input file. And here we go. This is a change. And so commit this. And now push the change. And that should be it. And then should be good to go. All right, so this PR will be good to go. We'll check the CI output in a moment. Now, this one should be good to go as well, but still has a CI failure, or maybe a couple. So now we're going to work on this. All right, it's already up to date. So what are the CI failures? Maybe there will be multiple. We'll see. All right, so there are a couple of errors. Let's see. So there are multiple errors. Okay, well, we will need to work on this now. So KV chords. What is going on with KV chords? KV client, KV chords. All right. So this is a local test cluster. Interesting. So that one. So what is S? Create test DB with knobs. It's here. And that's a local test cluster. We don't know exactly what that is, but it's here. Then it has a stopper. And then it has a start method. So let's abstract this. All right, so this has an ambient context, so that's great. So we are going to store this into the local test cluster. Like this. And then we're going to say maybe like this. And then like this. Like this. Oh, we want the CFG ambient CTX to be the same. Oh, well, I don't mind that. Okay. All right, so there is a tracer. And text is this. Okay. this. Sounds good. And let's try again. So what we just did, we made the local test cluster in the KV as test utils package, where context aware of the ambient context. Ambient. Okay. And now we can try it out. Mad Dimp just describes the stream. Thank you and welcome. And now we are going to do ambient context. Access. And then access. Is it not? Yes. Access. Okay. This. Okay, that seems to build. Let's see how that works. So this was a change in this package, and this was a change that was made in the commit a bit further up in the history. So let's see which one that was. Probably the first one, right? Yeah, that looks about right. So that's going to be the KV chord. Let's wait for the test to complete running. I am optimistic it will, but it's always good to verify. Trust but verify, and it did. Alright, magit commit instant fix up. It is in KV coords. Which one was it? This one. Off we go. Oh, Madam says whoa. So what is a whoa for? So we are getting some errors in the KV server package too. So let's try that. Tier declare but not used. All right. That didn't fail. Yeah, it didn't fail, right? I like when things don't fail. So this one we are going to do that is not good. Like this. More. It has a stopper. All right, I'm assuming this is running. While this is running, we are going to check which package this is testing, kvkv server. And check which of the commits here. So that's kv server reuse ambient context were appropriate in test. So that looks like this. So we are going to amend this commit. All right. So Madim says amazing Vim skills. Yeah, well, you are very generous. You are very generous with your comments. I would be even more generous if I was indeed using Vim, but I am not. All right. What other failure did we encounter? The TS package. All right. So you're asking what is that? Well, you see my completion prompt here. What do you see? What is the word just under it here? And what's the word you see under it here? Yep. All right, tracing tracer has now make them ambient context. All right. DB test. Make the me compute. Yeah, that should be a log like this. And which package did we see this for the last? In test utils, make them in context where appropriate, right? That would be this one. All right. Next error. In the server package. All right, admin test. And 320. There's the tracer. Oh, that doesn't exist anymore. Test server interface has no field or method tracer. I suppose that is true, but that is because this one is confused, is it not? This one is confused. Okay, so what do I do here? We don't have a tracer anymore. That is strange. So we're going to check that. Test server interface has no field or method tracer. It used to though. Util server test util server utils test server interfaces here. So we used to have a tracer. Now we have a tracer I. Oh. Ah, interesting. So what do we have here? We used to have a tracer and we don't have anymore. Hide the factory pattern. Tracer interface and tracer I interface. That's the one. It used to be tracer and now it's tracer I. Okay. And that would have been tracer I like this. And then We need to cast it. Cool. We probably have more of those, huh? We still have a test running asynchronously, right? Yeah, it looks like it. It's going to test a little while. It's okay. Let's build that here. And one more. Here. And then we're going to check which file. Server test cluster, use client ambient context. All right. So what change did we just make here? Trace R, trace I, all right. And verifies that our basal definition file is still defined properly. Looks like it. Uh-oh. We are missing one here. We'll see. Okay, so this one goes to server test cluster. The local test cluster, what did we have with it? KV code. Like this. Yeah, okay, so that's still running, that is still running, and so we had failures in those 3 packages, and that seems to be all for this one. Rochevet, same complaints, no more additional thing here. Then that is failing with the same, I'm okay with that. And then we have here unmatched back. Yeah, I'm okay with that. Copy. Come on. And that looks good. That was the last commit, so we can amend this. And now we have fixed our PR. That will be this PR here. And now we will need to wait for a little while that CI completes. But that should probably be good, and if it is indeed good and the CI passes, which we won't know very soon, we will eventually, that PR can merge. And that gives us now the opportunity to go to the next project. Oh, I just heard a noise. I heard a noise. The noise is telling us that something failed. So which one failed? We see here a fail. Maybe we don't. Maybe we do. A leaked go routine. Yeah, I might not care about that. Not sure. Induce panic for testing. Okay, I am not too concerned by this. This one is still running. And this one is taking too long. Test learner snapshot fails rollback. Let's investigate this test. Test learner snapshot fails rollbacks. That's this one here. Yeah, we didn't really change anything in that area, did we? Probably not. Oh, this test passed eventually. Alright, it's just very, very slow. Yeah, I'm not going to be concerned too much here. I think this is going to be fine eventually. So now we can focus on our main project for today, and that is this issue. So we have Go routines spawned by these methods here: stopper.run task, run async task, and some related methods, and they use context.background. That is not great. So I have a branch, which is, I believe, this one. And it's actually based off the other one, so we're going to rebase it on top of it. We rewrote a lot of those things here, so we are going to ignore those previous commits. And that branch has a few commits already. Before we started the stream, I was investigating this already. And so I have here a change to the linter, which I want to show. This linter here, it's a new linter, which says if you have a run async task X here with a direct context.background here, you get an error message that's forbidden, and you should use an annotated context instead, using ambient context, or otherwise propagate log tags. So that's the new linter, and using that linter, I was able to find all these situations here where we had a call to the API method with a background that was not annotated. And so in this code here, we have multiple instances that are in unit tests, like these 4, for example, are in unit tests, but there are some that are not, for example, this one. And so in those few commits already, I was already starting to do a few of those changes. So let me show you basically so far what I've done about these. So we had here run async task context of backgrounds, and so instead we annotate the context and then we pass it here. Then same story here. So there was already an ambient context, and annotate pass, and then here annotate pass. And so yeah, so that's a few improvements already, and so we are going to do more of this until all the things are done. So there were already a couple of those changes prepared. So the one for backup test is this one. And then to do this one, I extended the interface for the helper. So we're going to commit that together in a moment. Then we have the tenant dir srv, which is here. Then we have the simulation, which is here. Then we have the site transport, which is here. Then we have the replica test, which is here. The DSQL physical planner is here. Then we have the linter, which we added. The others that you can see in the list, server, info store, etc., have been committed already. And so what we don't have, so we stopped here. We need to continue basically automatic stats, tsdb.go, or maybe tsdb.go I already have somewhere. We'll see. And then the last 2 tests. And then after we done all this, we are going to commit the testing changes and then send that PR for review. Shouldn't take too much time. And if we are successful, I certainly hope we're going to spend the last remaining minutes in the stream. So this stream is going to be shorter than usual because I have a meeting at 3:30 in my time zone, which will be 9:30 Eastern. And so we will finish the stream perhaps maybe 5 to 10 minutes before that, so I get some time to take a break. And so until then, we will finish this PR and then write some documentation to explain what this mechanism is about, so that future people who are going to interact with this area of the source code will understand what all this is about and what we might be able to do about it in the future. So that's the plan. All right. So let's go to the automatic stats. Another one here. So the refresher. Let's see where this method is called. I hope that the language server knows how to search. Maybe we don't. Make refresher. It's in server SQL. So the refresher gets started here. So that's great. So this is in pre-start. So basically the refresher is nodes can be taught about this. This, like this, and then here we can say annotate context of background like this. And then in the server package here, we need to change this like this, and it's connected together. Great. So do we have more of these? Yeah, we have make refresher in the test file. Automatic stats. Stats test here. Right, so this is a server. Ambient context, okay. I think that would work. Yes. Okay. This. Yep. And then we can test this probably. Fingers crossed this works. I forgot one. Yeah. I'm somewhat confident this should work. So this goes together with this one. All right. Cool. Next one. DB, TSDB, I think we already did this one. No, not yet. All right, so we have a poller. P dot right. Let's make a commit with this. Periodic. Okay. And then the remainders will be probably stragglers for which we don't actually need. Different commits, we can probably merge them together. So we just have 3 now. Scanner test, stopper test, and your PC interceptor test. So that's scanner test in the KV server package, and everything else been done already. All right, let's go for those 3. All right. Okay. We don't have an ambient context here in Sesco, so we shouldn't be too anxious to be correct here. Test stopper num tasks. All right. Access, and then PC interceptor test 119. Does it have a context already? Probably. Access, and then we need annotated context, I suppose. Like this. Then we put all this here. Like this. Like this. And then now we have plenty of context which we can replace by having this like that. Let's do this. Oops, I have an alarm saying hi. Skip the alarm. Context background is going to be CTX. One here. Oh, there's one more here. Is that the same test still? Are we still in the same context? Yeah, it looks like it. Like this. And hope for the best. All right. Cool. We have modified all our tests, so now let's commit them piecewise. Austin just joined the chat. Welcome to the chat, and thanks for the compliment. Back up. All right, let's commit this. All right. The linter will be the last one we're going to use. So let's simply make a single commit for all those things together. And then say like this. And then the linter is the last thing we add, because this is the one that will block the addition of additional things. So we usually want the linter when it is committed to not detect errors in the same commit. And so we can say lint add a linter that requires annotated context stopper run routines. All right, that looks like we are done with this PR. Fingers crossed. Fingers crossed. Let's now, before we push this, let's recoup with our previous PR here, the ones that we were fixing up earlier, to see if that one is succeeding. And then we're also going to double check this one. So it seems to have a little hiccup, but maybe it doesn't have here. So we're going to do that afterwards. So let's see what the CI on the previous one is saying. Like, if there are still things to fix up, we need to do that, because we can't just send a new PR if the base is not right. Well, that looks... now we don't know much. Not many of those targets are finished. All right, so we have 15 commits in this one, and there will be quite a few in the new one. So let's see. And this is this one. Avoid using background statics in stopper.run sync task x. And then we have two reviewers. First this. Oopsie. All right. Come on, clear signees. Oh well, it doesn't want. Repository, DB, server security, individual commits for details. Fixes, this one. It's the first. How many commits here we were fixing real things like this one. 1, 2, 3, 4, 5, 6, 7. 7 of these are fixing what could arguably be described as observability. All right. The first 15 commits are from... Please ignore those during a review. So how many do we have here? 7, 8, 9, 10. This PR contains only 10 commits. Okay. And off we go. So this is a big PR because it contains 15 commits from the previous one plus 10 additional commits. But if one goes to the review tools, they will see that really like we are looking at extremely small changes, and so they are extremely easy to review. So so that's that. And I am quite optimistic this will pass. Yeah, if it does, we're going to issue a merge for this PR, so that the review for this one can skip over the first 15 commits. That will make it slightly more digestible. All right, so that will take a while because CI takes a while. So what can I say? As we're doing this, we are going to inspect CI for the first PI we were looking at very early during the stream to see if that is still failing somehow. It doesn't seem to be failing. Look at this. Look at this. We only have this Roche test finishing here. Everything else looks fine. So I think that despite this little cross here, that CI target is going to be fine. So I'm optimistic. All right, so what we're going to do now, we're going to reflect on the work from those two PRs, 72912 and 73915. And we are going to write a tech note that is explaining what's going on here. And I don't know exactly if we want to have a tech note or maybe a wiki page in the CockroachDB wiki. Maybe both. I think we're going to have a tech note, and then we're going to link to that tech note from the public wiki, something like that. Yeah, let's do that. But before we do so, it's been 45 minutes since we started work, and before we engage in a 20-minute task, it would be too much to do in one go. It's important to take breaks. So this is time for a break, and we are going to move a little and hydrate. And then after that, we can write our tech notes. So it's going to take maybe 2 to 3 minutes just to take a small break. And we're going to gather again at, say, 2 or 3 minutes past the hour. See you in a bit. All right, we are back on stream. Welcome to the new viewers. The work that we just completed was a fix to this issue here, which is this PR, and that is changes that look like this. Quite a few of those. Oh, sorry, not this. We have too many changes. Like this. In cases where we have run async task, context to do. Oh, that's again not a good example. Let's take a good one. This is a good one. Like run async task context.background we replace with run async task ctx, where ctx is an annotated context. Annotation means we connect the context to tracer and do and add logging tags and ensures that the traces in particular are connected to the server properly. So MacNulty88, welcome to the channel. So this has now quite a few. There's been quite a lot of work to do this ambient context thing, and so one thing that I want to acknowledge is that when I started working on this a long time ago, I had no idea what's going on. And I still don't understand much. But we need to talk about that here. So there is a tech note, and we're going to read these tech notes together, and we might enhance it by rewriting parts of it, because the knowledge in there is probably somewhat outdated. So let's see when this was last updated. Docs, tech notes, context.md. Oh, actually, it's been updated. It's been updated, but not much. All right, so we're going to read this text together. And when there are changes needed, or maybe we will need to do something else, to explain something else, we are going to either add paragraphs or maybe seed a different document. And I will try to give some explanation about what we are understanding from this text. So you might have noticed that much of our code base passes around context.context to functions all over the place. You can go a long way without understanding exactly what the point is until you can't, but that's no way to live. You might have heard that we don't like context.toDo, or that storing contexts instructs in bad, and you might be wondering what's that about. This document is to serve as an explanation of context-related topics. Great intro. So I'm going to add some note here. What is a context.context? It's an interface defined in the context package of Ghost and the library. The package documentation says package context defines a context type which carries deadlines, cancellation signals, and other request scope values across API boundaries and between processes. So the idea is that a context represents an operations context, deadline, cancellation, and values that we want to pass implicitly to all the function calls executed on behalf of that operation. This last use case may be achieved with thread locals in other programming languages. That's a key understanding that we're going to talk about more later on the stream. Maybe not today, but we will. The context package does not attempt to define what an operation is. That's up to the programmer. Typical operations are serving an RPC call, serving an SQL query, or periodic background activities such as replica rebalancing. An important point is that operations and contexts are supposed to be hierarchical. An operation can have sub-operations which may inherit the parent's deadline cancellation values, or may define their own. That's why the context package makes it easy to create derived or forked contexts. Child contexts inheriting and augmenting the parent's properties. This is the interface definition. You can read that from the Ghost Standard library. Motivations. At CockroachDB's, we use context extensively as a result of cascading pushes by different people for improving logging and tracing. Logging is about keeping a global history of the activity on a node or cluster. Improvements there aim to make messages more informative. Tracing is about keeping the cause-effect relationship related to individual activities, for example, individual client requests. Improvements there aim to increase the accuracy or usefulness of the network of cause-effect relationships tracked by individual traces. So that's a bit difficult to read. Tracing is about keeping the cause-effect relationship. Improvements to increase it. Oh, basically, we improve that area so that tracing becomes more useful. Go contexts enable CockroachDB to provide both services using a common interface. We like passing context everywhere, thus informing each layer of the code about the context in which every function is being executed. So the main benefits we get there is that all our log messages are prefixed with information about the components that's logging them, and that all the logging messages also become part of the current operations trace. Okay, so that's a good explanation of what context is. Still doesn't explain what ambient context is about, so we're not done there yet. Context for logging. Let's look at an example of components information being part of log messages. The following call, log info, blah, 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 results in the following message or being output, blah, blah. Notice all the prefix N1, S1, R1, etc. is not part of the logging command, the logging call. It's just prepended automatically through the CTX arguments that pass to the logging methods. The CTX had been populated with values describing the replica executing the operation that led to the range list acquisition. Node 1 store 1 range 1 replica 1 covering keys mean to table 1 0. The annotation happens before. This annotation happens because at the point where an operation entered the replica code module, we forked a child context containing all these annotations, and we use that child context for all downstream code. Everything logged on the replica module and downstream of it will carry information about which particular replica the operation using. Isn't that neat? Yes, I agree, it's very neat. Let's look at an example of log message containing information specific to the current operation. Here we see information about the client, achieved by having each of their SQL section create a context with annotations and using it. So we see as the client address is embarked here. Context for tracing, so now getting more closer to the problem at hand. Besides logging, tracing is also a big reason why we plumb context everywhere. A trace is a structured view of an operation. It contains all the logging messages printed by code servicing that operation, plus timing information about the sequential parallel nature of the operation. So some explanation of what gets emitted and where. The logging messages are the same as the ones that make it to the unstructured text log files that we discussed above, the amount produced by calls to blah, blah, blah. The trace consists of a tree of spans. Each span represents a sub-operation. So that's actually really a summary of a recall or recollection of what tracing is about. So it's really an explanation of how tracing works, but I think this is not the right place for this to be explained. But let's look at the final paragraph here. We use spans from package open tracing. That's not true anymore, by the way. We have our own spans type. And bind them to a tracer object. Context object that actually can carry a linked list of key value pairs. We store span objects in context to represent the stacking nesting of current operations in CockroachDB. Whenever logging method is invoked, the logging method inspects the context object from the head, checks whether it contains a span, and if it does, it extracts the first span from the context, sends a copy of the log event to its tracer before printing them to the log file. Creating traces programmatically. When thinking about how operations should be traced, the first decision to take what constitutes an operation. So we have a couple of explanations about how to create traces. And so we need to have a fix me here, talk about how to annotate plus trace using an ambient context. Context cancellation. Context make distributed cancellation easy. A context object has a broadcast cancellation channel which components can check to see if the work is still useful. For example, a context for the worker of a network connection will be cancelled by net.cont if the network connection is closed, and the worker can check that periodically and spontaneously abort. So instead of checking the error status by trying to send data through the connection. So this is really cool for things like backup restore logisticals that kick off a lot of work throughout the cluster. Of note, a cancelable subcontext of a cancelable context means there is a Go routine spawned under you for propagating the parent cancellation. So it still can be expensive. I don't know why that's relevant to explain in this mini doc, but okay, whatever. It's still a bit unclear how context cancellation crosses gRPC and libp boundaries. People are working on this. That is actually true. Technical notes. Integration between logging and context. All the logging methods take context. So there's some code here. All the operation topic with log tags. To add a component specific tag, we prefer different patterns. These tags are, and we have an ambient context. So this is where we see ambient context being discussed, but that's not good enough. We want actually ambient context to be discussed much earlier in this tech note. So that is a thing fix me refer to AC much earlier in the tech note. And I'm going to explain that a little bit earlier. Integration between tracing and context. Tracing interface, Lightstep tracer, its own tracer, Lightstep integration is enabled, all log messages. All right, what operations do we track? Where do we track trace and span? So multiple operation definitions. So that's not directly explaining the thing. But then we have here. Actually, let's summarize those paragraphs one by one. So use the same context for the benefit of sharing those client logging tags. All right. So that's the most important use case for debug events if finding operation that is stuck. Yes. I don't know what that means, but that's not directly what we need to discuss. When talking about tracing, you want to make operations make sense from a user's perspective, and I agree with that. Spans cannot be used after they're closed. That's true. It's a moment for SQL processing and operation in SQL transaction. Okay, all spans are under SQL transactions. Okay, this is a wise choice. Things like data collection of SQL result sets can span multiple client transactions. Don't we want instead to span over a batch of SQL code received by a single client message? Maybe. I don't know. Within a SQL transaction, there are many sub-operations. We're a little shy about opening child spans. Right? Our context gets derived a lot more for logging and cancellation purposes and for tracing spans. Every layer that has an ambient context technically creates a child context. That is not exactly true, but we don't necessarily think of these as representing logical sub-operations. Well, simply trying to put more information in the following log messages. In other cases, we do explicitly for a context to identify sub-operation. For example, the range descriptor cache identifies sub-operation worthy of having a log tag. Yeah, so that is explains the difference between simple log tags and sub operations, because they're not the same. Log tags are important to understand what's going on, but sub operations are important to understand the nesting, the API boundaries, and that is not explained yet in this tech note. So we are going to do a little bit of that. FAQs. What's wrong with storing a context in a queue? I don't know. But what about background operations? Oh, that's super interesting. That's where we probably need to talk about that much earlier. Besides interactive request response processing, there are also background work that happens periodically. For example, our queues do periodic processing. The queues have an ambient context that they use to annotate context with background in their main loop. So it's important not to put a tracing span in this context, since the trace would be very long-lived. Yeah. However, since a span is only collected when it's closed, we might never connect all these messages. All right, that's true. What's context.background, what's context.todo, and what do I do when I see one? All right. So there is space missing here. We want to use context.background as a root for most of our context. Okay. All right. Should be using never context.todo. All right. Alternatives. An alternative to passing a context around to most functions. Add some type of thread local storage to go routines. Yes, we are going to talk about that. And the objections to this, we are going to address them eventually. All right. So let's create a branch for the changes to that RC. Not RC, tech note. All right. And then start with fixing the typos. This one. This one. This one. This one. This one. This one. All right. Like this. And yeah, now we have a little bit of an issue, which is that we have really a couple of points that need to be discussed in that tech note. But in 10 minutes, I will have an important meeting, and so we can finish all of this today. So we're going to just sketch an argument at the top. Introduction. So we're markdown here. Markdown doc. Generate doc. Like this. Motivation for context. And then we can have this. And then there will be technical notes, alternatives. And then we're going to have this here. When CockroachDB needs to spawn an asynchronous, we want, in some cases, many cases, we want that task not to be subject to the same cancellation rules as the task that spawned it. Since the cancellation is a property of the context, we cannot use the parent task's context as a context for the new async task. However, a context.context carries other items of information that are important to preserve throughout the creation of asynchronous tasks and their children and grandchildren tasks, if any. Also carries other items. How can we achieve this? This is achieved via the ambient context abstraction. An ambient context, or AC for short, is a data structure that carries the common information that we want to share across all asynchronous Go routines under a particular CockroachDB server or component. For example, CAC contains a reference to the tracing tracer component. To a tracer component, explain. Used to collect traces. All traces related for a group of related asynchronous tasks. It also contains common logging tags, for example, the identity of the CockroachDB server that is spawning the coroutines. When a component needs to use a fresh context.context with a without being encumbered by the cancellation policy of another context, it can use context.context, then request the nearest AC instance to annotate this context. The annotation call annotate ctx propagates the common information to the new context, but not the cancellation rules. Conversely, it is very important to use ambient context as much as possible to ensure that the common information is effectively shared using context.background without annotation from any rest AC will cause the task activity to become detached from the identity of the component and invisible to tracing, logging, etc. Or invisible, unrecognizable in logging, etc. All right, and then we will need to process the other fixmes that we wrote here in a later phase. All over the place. And using ambient context is important. All right. All right, so we have a little section here about what is an ambient context, and we are going to add additional sentences later. But today, unfortunately, that is the moment where we need to end the stream, and the reason is that I need to be somewhere else in a few minutes. So that's that. For everyone who's watched today, thank you very much for your company. Even though the chat was a bit silent, I appreciate the company, and I really hope you have a great day. And we will hopefully see each other again next week. Have a great weekend. See you.